Okay. All right. Well, first of all, it's awesome to meet all of you. Let me share my screen. Yeah. Yeah, it's awesome to meet all of you. I'll say as well, like anyone, if you have any questions throughout, or you just want to ask a question, clarify something, make a comment, please feel free to just unmute and say something. Or if you prefer, you can also like drop a message in the chat. I've got it up in like a side window, so I'll see any messages coming through and I'll try and like answer it as it comes up. All right, it's awesome to be here. So yeah, my name's Sam. I'm the co-founder and CTO at Oso. As a company, our sort of mission is really around making security a little bit more accessible for developers. And I mean, it's kind of like the thrust of what I'm going to try and talk about tonight is sort of demystify this whole area of authorization. Yeah, so authorization is actually, it's kind of come up a lot recently. So here's like 3 examples of some like pretty large companies who recently have like done a bunch of work internally to build some version of authorization. So Airbnb, Slack, and Carter have all written these blog posts around the work they had to put in to build this like internal authorization system. Obviously, they didn't have all the stuff I'm going to tell you tonight, or they could have, maybe skipped some of this work. But that's kind of what I want to talk about is like how to let you build these systems yourselves. So what am I going to talk about tonight? I mean, authorization is kind of like the crux of it, but in particular, there's kind of like 3 things I'm going to keep coming back to. So first, we've published this series of guides called Authorization Academy. These are like not specific to Oso at all. It's just purely like best practices for building authorization. And they kind of walk you through all the things I'm going to talk about tonight. These guides go into like full detail on kind of everything you need to know to go and build this yourself in your own app. So I'll like kind of a lot of the stuff I'm going to talk about tonight will like talk about these like kind of conceptual pieces. I'm then going to go talk through them in like a real Python app. That's where the SQLAlchemy piece comes in particular. And I'm also going to talk about like what Oso does in this like authorization landscape. So, briefly, Oso, it's an open source library for authorization. And yeah, it kind of gives you all of everything you need to apply some of the patterns I'm speaking about tonight. Okay, so to start with, authentication versus authorization. Just want to kind of clarify those 2 terms because people often mix the 2 up. They are very related and they kind of do go hand in hand. So the way I like to remember though, which is which, authorization has got Thor in the name, so it's clearly way cooler and more fun. That's kind of all you really need to remember about the difference between them. This is the one I'm mostly going to be speaking about tonight. But like more practically, okay, like in the case of something like GitHub, the example of authentication will be you go to GitHub, it kind of gives you this like login page, right, where you enter your username and password. GitHub authenticates that you actually are who you say you are, and they kind of identify that, yes, you are Sam89. That's the authentication piece. Authorization is sort of what comes next. So like now I've established, who you are. What are you allowed to do? So it's kind of it's sometimes it's not very easy to see this quite so visibly in something like GitHub. But what you can do is you can try and visit like these 2 different URLs. So one is for like the Teams page for the Oso HQ organization, and one is the Teams page for the SQLAlchemy organization. And basically, I get 2 different views depending on which one I visit. In the first case, for Oso, it's pretty happy to show me all the teams at Oso. But if I try and visit the SQLAlchemy page, it like redirects me away from that page and gives me this little message to say, you're not a member. And this is really authorization in practice, right? GitHub has decided that based on its knowledge of who I am, there's one page I can see and there's another page I can't see, right? So authorization, it's all about this kind of like securing access to data, who can do what, who can see what, that kind of thing. So there's like a couple of like core pieces made up inside authorization. Like there's like a lot of distinct things happening, and they're in like different pieces, different parts of your application. One of which is enforcement. So enforcement is really around like the sort of the place in your app where you actually end up like asking this question, like, can the user do this thing? Is the user allowed to perform this action on this resource? Right, and in the case of something like GitHub, it might be, is Sam Scott 89 allowed to read the teams for the Oso HQ organization? Right, this is like classic like enforcement authorization in an application. So I'm going to show what this looks like in a little bit more of a concrete fashion. So I have in a different tab. So we have this like example app that we built to sort of show some of these authorization concepts. We call it GitClub because it's a GitHub clone. It basically does all the same thing GitHub does. I mean, you can see it's basically fully functional. But in particular, I can log in. Let's see, jonasbeatles.com. And so I already have. Oh, I'm not running it. Maybe I should run it first. That would help. Yeah, while I'm doing that as well, I should show. So it's this app. This is a Python Flask application. So you can see I'm kind of like creating my Flask app here, and I've got a bunch of routes I'm registering. And it's using SQLAlchemy as like the database model back in this. So all of the data lives in SQLAlchemy. So for example, you can see I've got like my organization model that has things like an ID and a name field and things like that. Okay, so that's my app. Now I should be able to just visit and be logged in. And yeah, so I can kind of go through and explore, and I've got, organizations, the Beatles, things like that. So this is my like base GitHub clone, my GitClub app. And so the question of like enforcement, like where does it come in? It's like, how do I control who has access to what? So to kind of make this more visible, what I've done is I've added this little helper method that's gonna kind of break down where I might do some authorization throughout my app. And kind of see how I can ask those different questions of who can do what. So let's revisit this page again. Okay, so I'm not going to see anything because I'm now I've got a breakpoint that's going to basically stop me every time, throughout my app. I'm going to like have various points where I'm trying to see what's the user trying to do. So I can do a little backtrace. Wow, this one's not so easy to see from the backtrace, but basically what I've done, I've added a little route handler down here that's going to do some request level authorization. So before every single request, this is a point where it can be common for people to want to like enforce authorization. So like on, the request is coming in, I'm like, okay, should I allow this request or not? And so maybe I'm, pulling the user off of some like global current user state, and like the thing the user is trying to do is make a specific request. So this is like pulling it from like the Flask context variable, and they're trying to do it to like the GitClub application, right? So in my my handler, I'm asking it, is allowed, and so that's what I'm like breaking on this point. So I can kind of print the args out and see, oh, actually the user is none. The action in this case is a request to some options endpoint, and the resources is GitClub app. So okay, like continue through, and I can kind of see there's like a bunch of different. Oh, maybe request wasn't there. Don't have any args now. Maybe refresh wasn't the right one to go with. Let's go with orgs. Let me kill this one and try this again. All right, so again, like we're trying to access this endpoint, and it's asking first for like the options, like a pretty typical like HTTP request, seeing what's allowed to do. Next, oh, I'm actually gonna like try and hit some session endpoint. Continue. Okay, now we're into like some of the real business. We've got a user trying to make a GET request to the /orgs endpoint. So this could be a good time to start doing some authorization. We're like, okay, is the user allowed to make a GET request to /orgs? So we can maybe decide like, yes, every user is allowed to hit the /orgs page, or maybe they're not, that kind of thing. As we keep kind of going through the application, so then we can maybe click through again, see another page, and again, we're kind of going through this process of like seeing what is the user trying to do, and like each of these are potential things we could like enforce authorization on. In this case, I've actually added another one. Should be, where is it going to get to it? Well, there's a lot of requests happening. Aha, here we go. So then finally, we might actually get further through our app, right? So we've gone through this, like each request coming in, and we've got to decide, should I allow this or not? And maybe options requests we allow through, and GET requests we let through. But what about when it gets to like the application code? So what about when I'm in, trying to read a particular organization? We might go through the same thing, right? So this endpoint to get one organization, org number one. You know, the user we can get as the current user. This time they're trying to read. And this time the resource is like an organization. We've just fetched one from the database, and we're saying, can the user actually read this org or not? Should I allow them to let that happen? Right. And so now we're getting like way more granular. We can start doing like more stuff on this. Like it's not just about like a request that's coming in. So now like the resource itself. So these are two examples of some like different enforcement patterns, which you could think of as like called like request level and like resource level. And it's kind of about like the granularity at which you want to apply like authorization. Now, what's kind of interesting to see in this one, you know, if can a user read a particular organization, we're going way more granular now. It's like this specific piece of data, like can they read this one or not? Whereas before it was like about the whole request, like any request that comes to the org's endpoint. And so basically, yeah, and so what I've done, right, in this like little helper here, I've just put this all behind this little isAllowed interface that takes in an actor, an action, and a resource, right? So again, like user trying to read an organization, that kind of thing. And this basically, this kind of like question, like what's user allowed to do, is like a really good starting point to think about what you're trying to enforce in your application. Like, what is the question you're asking? What is the, what's the thing you're trying to like decide on and on? So in the case of Oso, we provide basically an API, which is exactly this, which I can even just fill in here. So you have like on an Oso instance, you can basically call isAllowed. So if we wanted to actually do some enforcement here, not just return true every time, we could call Oso isAllowed. All right, so this is kind of like piece one, enforcement. It's like the code that goes in your application. It's going to be that like, kind of gatekeeper. It's the person that's going to just like, enforce what happens here. Is it, should I allow this thing or should I raise an exception because it's not allowed? All right. So that's kind of piece one. And the second piece is the decision, right? So if enforcement is the kind of the place where you pose the question, decision is how you actually decide what happens, like whether it should be allowed or not. So again, we said, like, is Sam Scott89 allowed to read teams for the Oso HQ organization? And maybe the answer in this case is like, yes, because actually Sam Scott89 is a member of, or rather at Oso HQ. And there's kind of like two pieces in this decision. One is like the data that makes up it. So, in your, this might be the, as we said, Sam is a member of the Oso organization, right? And that's like something that's going to be represented somewhere as data, probably in your database through, say, a SQLAlchemy model. The other piece is the logic. Like, okay, so we know that Sam's a member of Oso HQ, but why does that mean that he's allowed to, do a particular thing on, read teams, for example? And that's where we come to like the logic piece of it. It's how do you kind of combine the piece of data that you know, like what is the logic you apply to them? What's the rationale, the rules that you apply to those to actually make a decision? All right, so like data and logic, these are these like two core pieces of authorization that we'll kind of come back to a bit. Okay, so let's look at a demo of those again. So in the case of our Git Club application, as we said, the data is probably going to be managed through our database models, right? So a typical piece of data might be I don't know, let's say like I guess we don't have any in here yet, but maybe when someone creates, maybe there's like an issue creator or something. When someone creates an issue, it's captured in captured in the database, right? So the issue creator has some relationship with the user and so on and so on. Maybe this is, yeah, issues works. Right, this is like a piece of our data in our database that we might want to decide like who can do what, who can like read an issue or not. So maybe when it comes to writing like the logic piece, I'm just going to write it like inline here. Maybe it says allowed to read issue. I guess this can be self. Maybe this is like if user is equal to the issue creator, then like return true, right? This might be like a common piece of logic for representing like how whether someone should be able to read this issue or not. Now, the main point of Oso, one of the main reasons it exists, is to sort of avoid you from having to write a lot of this like duplicative logic inside your application, and like for this to be something that you can like manage throughout your application and kind of like write these like ad hoc things. So to address this, we have a policy language, and it's called Polar, and it's for the purposes of writing authorization logic. So again, so the language is called Polar, and it's kind of like a couple of like core pieces of it. It's a declarative language, which I'll talk about that in a second. You sort of express like who can do what by a series of rules. And finally, it makes use of application data, and that's gonna be like a really core piece for like how it can do its thing. And so the kind of core of writing these rules, it kind of mirrors that is allowed interface that I've been speaking about. So rules, it's as a convention, we have like allow as the entry point for this like policy logic, and it takes in an actor, an action, and a resource. But instead of it being like a method from before, like where we pass in the, we call it, this is where you're like deciding whether, should an actor be allowed to do an action on a resource. So it's conditional. You write like an if statement afterwards. So in our previous example, the actor was maybe was a user, and we said, they wanted to read an issue. And the logic we wanted to put was like that the user was actually the issue owner. Right, so this might be like a simple example of a rule you can write, and we'll see how like the policy allows you to kind of build that more complex logic. Just kind of talk through the pieces here. These inputs, they're coming straight from the Python application. So where I showed the isLoud interface that passes in these like Python variables, these are coming straight into the policy here. And so this piece here is actually checking that the first input is of type user. So it's from, it is an instance of the user model. The second input here is declaratively matching as a read action. So this rule will only evaluate if the thing you're trying to do is a read. And finally, the issue is again just like a Python issue instance. And so the conditions here, we're checking like the user as the issue owner. It's kind of how we represented that same logic from before, like an if statement. We're kind of comparing those two fields. And what's kind of interesting to see is that you can just reference attributes on your Python objects from inside Polar. And sort of what's nice about Polar and like the declarative nature of it is that you can kind of like write a bunch of these rules for who can do what. So, maybe you can, issue owners can also like delete an issue and edit an issue and so on. You can kind of write like, you can write kind of this in various different ways and like build up your rules and logic and things like this. So, maybe something like this. And so this is kind of like the quick intro to the language and the kinds of things you can represent in it. What I'm going to talk about next is like some of these different like models that exist for doing authorization, like classic, typical patterns, approaches people take. So the first, like what I'd say is by far the most common one, and especially in the context of like B2B, business to business applications, like your typical like SaaS apps. GitHub is a good example. They often use something called roles. You may also see this written as like RBAC. It's this acronym that stands for role-based access control. I don't really like the acronym, so I tend to just call them roles. So the general idea of roles, though, it's like starting from this kind of very unstructured problem of who can do what. It's like completely wide open. Anyone can do anything. How do I like break this down? So you have like a number of users, and you got a bunch of resources, issues, repositories, organizations. Like how do I go about like saying who can do what? Like, do I need to like assign permissions to everybody? So no, like the idea with roles is you say, well, really there's kind of only like a couple of different types of user in my app. Like most of my users are just regular members, and there's like a few of them are admins. And what I do with those is I say, oh, now I don't really care about the users themselves. I just have like a kind of a role for them. It's like a label. And I use those to say what they can do inside the app. So, members can read and write, and admins can read, write, and also delete. And that's kind of like the crux of role-based access control. It's like breaking down this problem into like fewer numbers of things you need to decide. So here's kind of an example from GitLab. So again, kind of in the same GitHub, GitClub style, example. A little bit more realistic here. So, GitLab, this huge application for, source control, but also, running CI and deployments and all this kind of stuff. But they still have managed to have just 5 roles. And each of these roles like corresponds to something like very intuitive of like your like relationship to the application, to like the organization or repository, right? So if you're, a guest of something, you probably can't go in and start editing and modifying things. You maybe get some like read level access, right? But you expect that a developer can actually develop and work on the app and like push code and things like that. So those are kind of like what the roles are doing. They're still like assigning those permissions to like an intuitive concept of like who the user is and what they can do. So yeah, so let's look at another demo for this. So we already have some of this set up inside our GitClub app, and I'm going to need to. What I'm going to need to do, I'm going to need to add some policy logic because now we're using Oso. Let's say that all requests can be allowed to GitClub app. Oh, like this should have worked. What did I do wrong? Oh, do I still have my debug printing in there? Yes. Okay. So we already have like some concept of like of roles built into this, but just kind of like talk you through them again to put them in the context of our GitClub app. So what's kind of typical in roles is you have like organization roles. So here we have like the Beatles organization, and we have some people inside it. We've got John, Paul, and Ringo, the Beatles, and they have different roles inside the app. So John is an owner, and Paul is a member, and so on. And you can see I can kind of like essentially invite new members to this app. But we also have repository roles as well, right? If you think about like inside GitHub, for example, like you might have an organization role, but you might also just be invited to just like one repository. And so you actually have roles here as well. So maybe we've also got Mike has been invited as a reader to Abbey Road, that kind of thing. So this is kind of what like roles would look like in the context of an app like GitHub. And the kind of challenge becomes like, how do I decide like who's allowed to do what, like using that logic of like, anybody who is anybody who belongs to an organization can like read the organization, they can like read repositories inside it, they can create repositories, things like that. So what we've done in Oso is we've actually like provided a kind of a template for doing role-based authorization inside an app. And so it looks something like this. So we've kind of taken our rules that we saw earlier to kind of the next level here. So I'll kind of walk through this like piece by piece. So for example, we're saying we have a resource, its type is organization. Again, that's coming from the SQLAlchemy model. We give it a namespace org, and it has some actions and roles. So the actions would be, all the things I can do to an organization. Like I can read an organization, I can create repositories for it, list repositories, and then kind of so on, so on. The next thing I need to do is basically say who is allowed to do these actions, like who can read, who can create repos, things like that. And that's where roles come in, right? So I might have a member role, and members of an organization are allowed to read the organization. They can list the repositories inside the organization and things like that. Whereas an owner, we might also give permission to do things like create repositories and some other permissions. Now, we probably don't want to have to like repeat and copy and paste this like list of permissions we've granted to each role. So we also have this like concept of implications. So a role implies another role. So if you have the owner role, it implies you also have the member role. And in that way, like, I kind of have this like hierarchy of roles without needing to like duplicate myself. So this is like, this is kind of like the core idea of like the role-based access control model, right? It kind of breaks down to this data, basically. This is kind of like, I shouldn't say data because that's kind of maybe mixing up with what I was talking about earlier. Like the application data in this case will be this assignment of like users to roles. John is a member of the Beatles organization, whereas like the authorization model of roles, it kind of says like, if you have a role and the role is allowed to do a thing, you can do this thing. And that's kind of what's being captured here. So the next kind of model I want to talk about is relationships. This is one that doesn't often kind of get spoken about as much, but it's like a very, very powerful like mental model for like a lot of authorization logic. And basically what it looks like in, again, something like GitHub is these kind of graph-like structures. And a lot of this is just following your application data models. So, I have organizations and I have repositories that belong to organizations. So an organization is a parent of a repository. Repository is a parent of issues, right? An issue belongs to a repository, things like that. And this is just regular data that exists inside your application. We spoke about roles. Now, roles are basically just a kind of relationship. Like a user is an admin of an organization, or a user is an owner of an issue, things like that. These are all just kind of forms relationships. And the sort of these are like really powerful to use when it comes to like the way that you combine authorization data and logic. So kind of building on what we have here in GitLab. So going back to my models, right? So I have repositories and they belong to organizations, right? That's my like core piece of application data that I want to leverage. Now, if you think about something like GitHub, right? If you have a role in an organization, you don't need to then go and like individually grant access to every single repository, right? Like you somehow like it kind of flows through from the fact like you're in the org, so you must have some permission in the repository. You might not have like the full permissions, right? Like if you're a member of an org, you might not be an admin of a repository. And so kind of the way that's handled is through relationships, basically. So going back to like the Oso policy we have for this. So I already have like a role definition for organizations. I can also define a role definition for repositories. So I can be, a member or an owner of an org, but I can also be an admin, writer, or reader of a repository, right? So I have these like two sets of roles that grant different pieces of access, right? Like I need to be a repository reader to read a repository. Now, the way these are like tied together in like a relationship-based model is kind of expressed down here in this little parent-child rule. And so this is saying that this rule here, again, written in Polar, it's saying that an organization is a parent of a repository if, and it's just doing a simple attribute check, like that the repository's org field is equal to the parent org. And this is going to leverage that SQLAlchemy data to make the authorization, to evaluate this piece of logic. And like by doing this, I've now like tied together those data models. I can now start representing things like permissions that flow between organizations and repositories. So in this case, I say like an organization member implies you're a repository reader. An organization owner is a repository admin, right? So this like little piece of logic here, it's like if you are a reader, if you're a member of an org, you're the reader of a repo. If you're the owner of an org, you're the admin of any repo that belongs to it. And that belongs to it is like the important piece that like ties them together. So this is like a really common model that you kind of may like, I think people may not often just like recognize that it's a distinct thing because it's just like naturally encoded in their app data. So similarly, we might have like, a repository reader is allowed to read any issue that belongs to it. Like I don't have distinct roles for issues. I just want to like directly kind of like allow my permissions to kind of traverse that relationship. And so with this in place, you can start like representing like pretty complex logic. Like, I am a member of an org, which means I'm a reader of a repository, which means I'm allowed to read issues that belong to it. And that's all this kind of stuff that GitHub is doing, and just like lets you work. It just works seamlessly for you. You don't think about it, but it's actually controlling each piece of access like that. The final thing I want to talk about is attributes, also known as like attribute-based access control. And really, there's not really much more to demo here because we've kind of already been looking at it. Like the policy I wrote at the beginning, I could write maybe something like, allow a user to read a repository. I guess it's repo if the repository is public. So attribute-based access control kind of just like covers everything because like relationships is a form of attribute, roles is a form of attribute, but kind of where it goes beyond them is it's like some of these kind of like special rules, things like checking an attribute, is it public, is the user blocked from the repository, or is the repository deleted or archived, things like that kind of are covered in this like umbrella of attributes. Cool. So that's all the things I want to talk about tonight. If you want to like learn any more of this, basically all the stuff I was covering today is like covered in like way longer detail with like examples on kind of like the schema models you can apply. Yeah, the schema models you can apply to like do some like the simplest ones like just org roles and like the logic that goes along with it, and along with like advice around like when you should be using them. Yes, I was going to paste this in the chat. There we go. Thanks, Doug. Yeah, so we have a bunch of these guides that will kind of like walk you through all of the concepts I've spoken about today. So in particular, like from an architectural level, like where's authorization fit in, these like models like roles and relationships, and the latest one, which is like coming back to the enforcement idea, which is like where should you do it? Should you do it on every request, or should you do it on like the resource level? And then, yeah, if you're interested in learning more about Oso, and again, I'll copy these into the chat. Here are some links where you can find out more about us, in particular, like who we are as a company, documentation on the product. Everything I've been showing tonight is all part of the open source product. So you can just go and download and use that whenever you want. We have a kind of growing and very, very helpful and friendly Slack community around Oso and authorization in general. You can join, or you can see all the open source code at the GitHub link. But yeah, that's everything I wanted to cover. So thanks everyone for listening, and yeah, happy to like take any questions that people have. I'm gonna have a sip of my drink.
So cool. We're in Q&A, guys. If you guys have any questions, that was a great presentation, Sam.
I have a question, I guess, while other folks are thinking about what they might ask. So I may have missed this, but like, how do you, like, what is the magnitude of, I guess, the SQLAlchemy integration here, right? So if I'm saying enumerate all organizations to which I may have access, like, am I getting all of the organizations and checking them on the application server, or is that getting proxied to a database query?
Yeah, thanks for reminding me, because I completely forgot to cover that piece of it. I was too focused on going through the different pieces. So, okay, so picking up from the enforcement angle, right? So I spoke about you can maybe do enforcement on like a request. It's like quite coarse level, like on the whole HTTP request. You can do authorization like over a particular resource, like can the user read this org? But what about if you want to do it over like an entire list of things? So in particular, right, I have an index, get all the organizations. You'll notice in this method, I don't have like any is allowed calls. And so like in theory, I might want to do like for org in maybe something like this. Like the naive way to do it, you say for every org in this query, like if Oso is allowed, if the user is allowed to like read this org, then like, I don't know, like add it to a list. No, right, so this like would be like the naive way to like do that enforcement across that whole list endpoint. You go through and you do like authorization individually. This would be like the resource level version of it. So there's a kind of another concept for enforcement called that we call query level authorization, where you're doing this same kind of checks, but you're pushing it down to like the database level. So instead of it happening like inline in the Python code, you're like, actually, I want SQLAlchemy to handle this as part of fetching the data. And so that's actually what's happening through, if I just go and undo all this, that's actually happening through this little decorator up here. We're using the Oso SQLAlchemy integration, which creates an authorized session. And basically, what it's going to do, it's going to apply authorization to the database query. And so you can kind of see we're passing in through here, like these are the permissions that the Oso SQLAlchemy integration should check. So you should check that the user can read organizations. So what this is actually going to do, it's going to take the policies I was showing earlier, right? So the role-based policies, or any of these relationships that we've defined, or any just like one-off permissions that any user can create an org. It's going to take those permissions and actually convert them via SQLAlchemy into a database query. I wonder if I can. I know what I can do. I think if I put it in here. So if I try and run one of these endpoints again. Yeah, let's see. So you can actually see, for example, that we've compiled this down to, we have this whole like this whole SQL query that's actually going to go and like do the whole SQL query to find all of the roles that the user has for the organizations, right? Because to evaluate can a user read, like which organizations can a user read, you need to find like all of the roles the user has for all those organizations. And similarly for like repositories, like all the roles the user has for repositories, orgs, and like do the kind of join over all of them. So you can see like basically down here, the like the end result is the query. It kind of just comes down to just like get all the organizations where effectively the user is allowed to read them.
Sam, I had a question actually.
Yeah.
That .polar file. So that's like sort of like a DSL for authorization here.
Yeah. So it's actually it's a logic-based language. So if you're familiar with of like Prolog, it's kind of like a Prolog. And so it's like a full-fledged language basically, and you can kind of use it for kind of writing any logic programs. But in particular, there's like a few features that we added to it that make it like particularly good for authorization. The main one being this like ability to integrate with application data. And so you can, let me do it here actually. So basically you can actually just try this out straight away. So you can go like basically pip install Oso to like install the Oso package, which I obviously already have. And you can go python -m Oso to like run, if you like run the Oso binary, it drops you into this like language REPL. So you can actually go and start like trying out this language. And as I said, it's like a logic-based language. So it kind of operates in terms of like queries. You're like asking it like, for what values is this thing true, right? So like super simple one, x equals 1. If I do that as a query, I'm asking for what values of x is x equal to 1? Well, x is 1 is kind of the obvious one. But I can also say things like, x is in 1, 2, 3. So I'm not like declaring the valuable x and doing like a for loop. I'm kind of querying for what values of x is this statement true? So it's true for 1, 2, and 3. And I can start like chaining these together, right? So an x must also be greater than 1, right? That's true when x is 2 or 3. I can actually start doing like kind of crazier things and say, and like start messing around with the order of these. So I can say, well, x must be less than 3, and x must be in this list, and x must be greater than 1. And this is where like the logic declarative aspect comes in. It's not like going through imperatively executing. It's like trying to find solutions to this. Now, the kind of like natural question is like, okay, like why is this good for authorization? The thing is like authorization tends to consist of like a lot of these like branching conditional things. When I showed the logic earlier, this is like the flowchart that I came up with for checking if a user can like read a repository, right? So you like go through this like crazy flowchart. It's like, okay, well, like, do they have a role for the repository? If so, does the role they have give them access to the repository? If not, let's go check, do they have a role for the organization? Does the organization role imply some role for the repository? And if so, does that, it like goes on and on like this. Like there's a lot of this like kind of logic that goes through. And so by having something that's like declarative and logic based, it allows you to like really compress that logic a lot, which it's kind of hard for me to show here because a lot of it has actually been hidden through these interfaces. You can kind of see it a little bit, like where, even this like top level thing is kind of being flattened. It's like we just have like a few of these little rules where it's like, well, any user can see another user, but only users can only see their own profiles, and any logged in user can create a new organization. And this all kind of like stays very flat, and it can start like building up pieces of logic and combining them, like the policy that backs this role implementation. That would be cool to show. Let me think if I can show that actually. Probably if I go to oh no, I don't have access to it here. Well, I guess I can always just so there's kind of like two parts to this. Like one, the language is like very good for representing this authorization logic. And the second piece is we kind of don't want people to have to learn a language. So we've actually, that's why like we have that like roles interface that you sort of don't need to worry about the logic.
This is written in Rust though, right?
The language itself, yes, is written in Rust.
I have so many questions, but I won't give other people opportunities.
Let's see if I can find the built-in roles.polar. Here we go. So yeah, so like here is like the internal code for our like role implementation. And so it's kind of like breaking down the logic into like all these different pieces. So it's like first, find if a role is defined. Next, like check that these are some internal ones. So like check that the role has a particular permission, check that they're like the user doesn't have like a role up the hierarchy that has some permission, and check the user can actually have that role. And so we've kind of like broken these like pieces up, and then each of these can be branching. So you can have a role if you have the role directly, if you have the role by implication, you can have, and so on and so on. So it's like all these kind of like branching logic that gets like flattened into these like pretty concise policies. But yeah, we didn't want people to have to write this logic, which is why we've kind of provided it built in. So that's a little bit of a tangent.
I have a question. So we've talked about this implementation, but I always think, how do people get their head around what direction they want to go with authorization? How do you get people on the road to like planning so they can use this effectively? Because when we're with your tool, we're at the point of implementation, and I'm like, oh, have I really thought through my model of how I want this to work?
Yeah, so that's a great question, because I do actually think that's kind of like one of the hardest problems of authorization, is like figuring out what you want to do. So that's like one of the things we've addressed through Authorization Academy. So like if you see here, we've got like all these different role-based models. These are effectively like sort of like 4 different progressions of role models. And for each of them, we actually go through and we say like when you should use it. And so like a lot of authorization modeling, like realistically, you could implement any model and you could make it work, and like, to different degrees of maintainability, like you could make it work. But where it really like matters, in my opinion, is the sort of user experience. And so like a lot of what we're trying to do is like help people be able to like map intuitive kind of concepts of authorization, like through things like relationships, like, oh, this belongs to this, therefore you can access it. Like I think a lot of those people can kind of grasp in their minds, but it's not always easy to translate that into implementation. So we walk through each of them. We say like, hey, this is appropriate for this kind of thing. Like if you want this kind of user experience, do you have like, does every user belong to just one organization, or do they actually have multiple organizations? Like in GitHub, I can belong to as many orgs as I want. But like maybe in a HR expenses app, doesn't make sense because everyone only has one company, and until you think about, I don't know, contractors or something like that. So there's kind of like, depending on your application domain model, there's like different user experience trade-offs that you want to think about. I think once you have those in your head, like breaking them down into those little like constituent pieces, where like you think about like a user can delete an issue if they were the person who created it, that's a relationship, or they have like a permission in the repository and they like have a role for the repository, and there's like the different versions they can get that. Like each piece of that might be kind of simple, like issues in a repository, user has a role for a repository, but it's like combining all those things together can get really difficult. And so like what we're trying to get to with like this policy that I was showing is that you can actually think about each of those individually. Like I just need to think about like whatever org belongs to a repository. That's just my application data model. Like there's no thinking that goes on there. It's just like, yep, orgs and repos issues. But by like telling Oso this, I can now start writing these like, I can now start having that discussion of like, what am I trying to model? Like, should an issue have a role or not? I think that, there's an argument that maybe you should have like an issue editor, because I want to be able to assign someone like, hey, you're, it's in Jira or something. Hey, you're now the one who's triaging this issue. You're the issue editor, but you don't have any other access. But maybe you don't have that use case. You only care about what permission they have in their repository. So that's all you need to think about. And so that's kind of the idea.
Yeah, I can definitely see this at a whiteboard, like before we're like, in a team, as we are saying, how do we want to do this, and going to this page and starting to write, because this is something you could write on a whiteboard.
Exactly. And I could, if I wanted to try something different, I'm like, okay, no, I do want those issue roles. Well, I can just like go straight in and start doing them. I can say, this implies that you're the issue like editor or whatever it is, and so on. On like the whiteboarding piece specifically, where we want to take this next is like one of the things we want to work on next is visualizing what's going on here. So you've told us relationships, you told us roles that we can actually then like show it to you visually, like here's what's going on. So it becomes that kind of like, I don't know, conversation almost, like, all right, here's what you've said. Is that what you were looking for? Is that right? Yeah.
Thank you.
That's a great question.
I have a question quick. Does Polar get compiled down, and like, does it show if there's like conflicting roles or permissions?
So it's an interpreted language. So it's not compiled, but it will. We do have some like validation built in. So if I think, for example, let's try this out. If I typo like reader here, what I should get if I was actually running the app. Let's not do this one. I thought we had some validation logic built in that would actually catch typos there, but we have like some validation that will happen to check that, like, maybe if I delete one of these. Oh, I haven't called the validation. Oh, that's why I didn't call validation somewhere. I can't remember the API for it. I need to call the validate method. But yeah, we'll like go through and like validate that the structure of it looks about right. That's kind of like one of the main things. Yeah, there's some other upcoming work we're doing around that, like from ID integrations that will tell you if your policy looks off to other things like that.
Cool, thanks.
Do we have any more questions, or should I stop recording?
I have one more question, and if this perhaps is getting too in the weeds, by all means, feel free to tell me to like go ask on a GitHub issue or a ticket or whatever. But so some of those rules are kind of hard coded into that policy file. What if I were to maybe want to push that up into maybe the application layer of saying, well, somehow in memory, I'm going to maintain or in an external data source that's not local to where my data is stored, storing those rules. Is there some like nice JSON format that I can kind of pass in, or are there maybe concerns around that sort of implementation around things like garbage collection? I don't know how necessarily.
Yeah. No, it's a question that comes up a bunch. I mean, generally, typically our response is like, you should treat your policy logic as code. It lives alongside your application code. You should sort of change it have the same mentality for changing it. So it should go through CI, it should be tested, and so on. Anything that's like dynamic logic tends to come from like the application data. So things like role assignments, like I can change what role someone has, and like dynamically the permissions, everything's updated what they can do. There are like some use cases. I mean, even like custom roles, for example, where you can actually like allow users to create roles and say what those roles can do. That's still like application data that you can like, the logic you can handle through the policy, but the data stays in the app. So we're really getting into the like, I'd say kind of like the niche use case where you need people to be able to, like your users to be able to granularly configure the authorization logic inside your app. And at that point, you're kind of in the territory of like letting your users like write Python code and submit it for you to run, basically. So we don't tend to recommend it, but you can just like store policies as a string and like load them in at runtime and like use them to evaluate different logic. I'd say, yeah, it's not something that we recommend because it's not something that we've like put a lot of work into supporting. For example, the concerns of that being, if you let your users write policy codes, then there is like the possibility that given that they can access the application data, that's like very possible for them to just like start arbitrarily messing around your app. Cool. So yeah, we have ideas of how to address that by like running user provided code in like a sandbox, but it's not something that we currently have.
Awesome. Yeah, thanks.
Do we have any last questions? Okay, I'm gonna stop the recording now.